Here's a pretty interesting improper integral problem. It's pretty popular. It shows up in just about every calculus textbook that I've ever seen, and it also has a pretty surprising answer as well that we'll look at in just a moment. All right, so it's obviously an improper integral because of the presence of these infinities. What's a little unusual is usually they don't put two infinities. Usually it's like from 5 to infinity or negative infinity to 0 or something like that. But here we're actually accumulating area from negative infinity all the way to infinity. And so it's pretty clear what we're after. If here's the graph of 1 over x squared plus 1, then I want the entire area under this curve from negative infinity to infinity. Now, the answer is not automatically infinity. If this function gets to 0 quick enough on both sides, then in effect it kind of pinches off the amount of area that you would get, and even though the function continues on to infinity, the area will be a finite answer. So that is definitely a possibility. Not 100%, but it's at least possible. Now, what do we do? Now, I know the typical trick when you have infinity as one of the limits of integration, then you make up a limit as like b goes to infinity, and then only integrate up to b or something like that. But here I've got an issue of having two infinities. And so this is a common trick when you have negative infinity up to infinity. You actually take this guy right here and break it apart into the integral from minus infinity up to 0 of 1 over x squared plus 1, and the integral from 0 up to infinity of 1 over x squared plus 1. And so in effect, you're breaking this up into two improper integrals. The first one here is going to cover this half. I'll color this in pink. All right, so this will be the pink half right here. And then you'll have, we'll just call it the green half, right, which will compute this area. And then that's this part right here. And then we get these two answers, and we'll add the answers up. Now, for this one, it just happens to be symmetric, you could just take one of these answers and double it. That's okay too. Normally, we're not quite that lucky. Now, one thing to note before we go on with the algebra, I did not have to split this at 0. It was just seemingly a nice number to split it at. I could have gone negative infinity up to anything, to 5, and then gone 5 to infinity for the second half. It doesn't matter at all, but I think for this one, 0 would be a pretty nice split. Okay, so I think we know the drill. We're going to take limits of these guys as like b goes to negative infinity or b goes to infinity or whatnot. I use different letters just to eliminate any confusion. So for this guy, let's take the limit as well. Let me keep the colors straight. Let me keep the colors straight just so there's no confusion. The limit as b goes to negative infinity for the integral b up to 0 for 1 over x squared plus 1 dx. And then in green, let me switch colors. All right, and then green here will go the limit as we just need a different letter other than b. We'll do like k. K goes to infinity for the integral from 0 to k of 1 over x squared plus 1 dx. Okay, very nice, very nice. All right, so let's do these separately. I'll do the first one in pink. What is the integral of 1 over x squared plus 1? Well, we know that well. That's the arctan integral, right? Arctan. So we'll be taking arctan of 0 minus the arctan of b. Arctan of 0 minus the arctan of b. Okay, so let's write that down. We'll have the limit as b goes to negative infinity of arctan of 0 minus the arctan of b. Okay, so that's the first one. All right, and then we're going to add to that the limit as k goes to infinity of basically the same thing, arctan of k minus the arctan of 0. So So arctan of k minus the arctan of 0. All right, now if we're familiar with the arctan graph, which I'm very, very small, sketch it up here. The arctan graph looks something like this, if you recall. Okay, it has a horizontal asymptote at, I believe it was pi over 2, and it goes through 0, 0. So the arctan of 0 is 0. So that's gone, and this is gone. And then let's actually look at this one first. I think this would be the most clear one. As k goes to infinity, what does arctan of k level off to? Well, it looks like pi over 2, right? Looks like pi over 2. Right? Now, as b goes to negative infinity, where does the arctan of b go? So as you go this way, looks like you level off to negative pi over 2, but there's an additional negative outside here as well. So you have negative pi over 2. So that makes pi over 2 plus pi over 2. So your final answer would just be pi. Right, just be pi. And that is such an interesting answer. That's a wild answer here. And there's actually a lot more I could say about why that answer turns out the way that it does, but that would make for an awfully long video. But for now, let's just kind of be amazed at the fact that this guy's integral, which just doesn't have anything trigonometric about it or geometric about it really, but the area under this guy's curve from minus infinity to infinity winds up being a nice even round pi, right, of all numbers. It's pretty amazing. And so this improper integral here converges. And so we'll typically need to say that word somewhere, because they will typically ask us on a test if this improper integral converges or diverges. And since this was a finite numerical value, we say that it converges.